Okay, Unit 1, Lesson 1. We're looking at order of operations. You've probably heard of several different ways to memorize this, and we'll kind of go over, the main one. Learning targets. I can use the order of operations to simplify expressions, and I can evaluate expressions using the order of operations. So first off, the mathematical order of operations is used to simplify expressions correctly. Again, we're simplifying. That may mean getting a numerical answer. That may mean not getting a numerical answer. Maybe just like changing it to a slightly different form. An expression is a mathematical phrase, which means that it does not have an equal sign. Okay, so it's just an expression. We're not solving for x yet. You probably remember doing that a lot last semester. We're not quite there yet. An acronym often used to help us remember the order of operations is PEMDAS. Okay, and each letter stands for something different. Okay, so P stands for parentheses. And you want to do as much as possible within those parentheses. Sometimes parentheses kind of mean different things, as in you may not be able to simplify everything inside of them yet. Maybe it's already simplified completely. But you do want to start with what's in parentheses, simplify them first. E stands for exponent. Once you've done all the parentheses and exponents as far as you can, you go to multiply or divide. So division. And these kind of run together. They're equal to each other. They are not. It's not that multiply comes before division always. It's that they are kind of in the hierarchy. They are worth the same. And then A stands for addition. S stands for subtraction. Same idea. Addition does not always come before subtraction. They are equal to each other. The tiebreaker then, the reason why we put boxes around a couple of the operations is because these two operations are done as they appear from left to right. Okay, so from left to right. So if you look across the board and there's lots of multiplication and divisions, start going from the left. So for example, this left guy here, or this first guy, couple different ways. If we were to multiply first, so if we were to multiply this guy first, we'd get 8 divided by 8. So you'd get 1. However, if you do the division first, so if you do the 8 divided by 2, you get 4 times 4, you get 16. So the order does matter. The correct answer here is, if we start from left to right, it would be 16. We should divide first and then multiply. Okay. So some examples down here below. Yeah, I'm looking at this. Look for parentheses first. Okay, so what parentheses do you see? I see parentheses here. I'm going to rewrite everything else. Don't change a thing. Okay, so 14 plus 3 is 17. So now all my parentheses are gone. Are there any exponents? Yes, there's exponents. So do the exponents next. Again, not changing anything else. I'm just going to replace the term that has an exponent, so 36. And now I have addition and subtraction. Again, that's a tie. Addition, subtraction, that's a tie, so I go left to right. The tiebreaker is from left to right, so I'm going to add first. Okay, so if I add first, I get 68 minus 17, and that equals 51. Okay. Here I've got addition and division, the only two operations in the whole problem. There's two of them. Which one comes first? Well, here's division, and there's addition. So division comes first. So I'm going to divide first. So I've got the 1/4, I'm just going to rewrite it, plus, and think of it this way. So in parentheses, I'm going to divide. Well, we talked about with our fraction view, when you divide by 2, that's like multiplying by the reciprocal. The reciprocal of 2 is 1/2. Okay, I've got 1/4 plus, again, I haven't really executed this operation yet. And if it's multiplication division, you go straight across. So 3 times 1 is 3, 5 times 2 is 10. Notice there's nothing there that reduced, that's why I didn't worry about reducing. Okay, so division's out of the way. Now I'm going to do the addition part. And like we reviewed yesterday, addition, you have to have denominators. So think the 4 and the 10. What's the smallest number that's divisible by 4 and by 10? Or what's the smallest number that's a multiple of 4 and a multiple of 10? The smallest one is 20. So I want to get these to 20ths. Now what do I multiply 4 by to get 20? It'd be 5. It's going to multiply the top by 5 also. 5 times 1 is 5. I'm going to double check myself. 5/20ths reduces to 1/4. So I know I got that right. What do I multiply 10 by to get 20? Multiply by 2, so multiply the top by 2. Okay, so 5/20ths plus 6/20ths, and almost think of the 20ths as units or as a label. So 5 apples plus 6 apples would be 11 apples. So 5/20ths plus 6/20ths is 11/20ths, and that does not reduce, so that's your answer. A little bit faster here, I've got subtraction and addition, and that's a tie. So PEMDAS, that's a tie. So I go left to right. So I'm going to do 12 minus 4 is 8, and then 8 plus 3 is 11. Let's see, the last one. I got a whole bunch of stuff going on here. I have some, these are called brackets, and these are the parentheses. So when it says parentheses first, do everything inside these brackets first. Within the brackets, I've got several operations. Kind of ignore everything else. Just ignore that 5/3 for right now. Within the parentheses, I got 2 times 9. It's 18. And then within these parentheses, I've got 15 divided by 3 is 5. So I still have a 5/3 hanging out front here. Inside here, all my parentheses are simplified. Even though I wrote a set of parentheses here, it's 5 on the inside. There's nothing else to simplify. So 5 squared is 25. I got 18 minus 25 times 5/3. And these count as a set of parentheses. So I'm going to go 18 minus 25 is -7. I'm going to put that over 1 since I have a fraction on the outside. So 5/3 times -7. Remember, when you're multiplying fractions, multiply the top, multiply the bottoms. So this would be -35 over 3. Okay? Remember, with these, if I go too fast on this, you can always pause the video and pause it, go back, replay it, see if it all makes sense to you. When we evaluate an expression, we are replacing a variable. So again, we're evaluating an expression. Now, we're not simplifying, we're evaluating. So we're going to replace a variable with a number. When we're doing this, it's a good habit to use parentheses whenever you do it, whenever you plug in. So I've got this expression, 3x plus 2y, and I'm supposed to let x equal 5 and y equal -2. Without knowing this information, I'm done. I can't simplify that anymore. But once you tell me what x and y, what the values are of it, I can keep going. So 3, take out the x, put a 5 in its place, take out the y, put a -2 in its place. Now it's just like the front side, got an order of operation. So I've got multiplications and I got additions. Well, all the multiplications come first. I technically should go from left to right. It doesn't matter in this situation, but I should go left to right. So 3 times 5 is 15. 2 times -2 would be a -4. 15 plus -4, 11. Number 2, I got 2/3. I'm going to put it over 1 since the fraction there. Okay, So multiply the tops, that'd be 10, multiply the bottoms. Now you got minus negative 4, so I'm going to make that a plus 4. Okay. Now this is technically over 1 right now, so the least common multiple would be thirds. So 10 thirds plus, I have to multiply the top by 3. So this would be 12 thirds. Again, if you took 12 divided by 3, you get 4, so I know I did it right. Add those together, you get 22 thirds. And it's okay, just leave that in proper. You don't need to tell me that it's, 7 1/3. You can if you want, it's not a big deal. Okay. Number 3, I've got 2, again, substitute the 5 in, minus 7. Now all that's in parentheses, times 1/2. Because I'm multiplying by a fraction, I'm going to make it a fraction. So negative 2 over 1 plus 3. Simplify everything within parentheses first. So I can do these parentheses first. So this would be a 10 minus 7. This multiplication comes before subtraction. So that means this is a 3 inside here. Over here, 2, or if I multiply the tops, it would be negative 2 divided by 2. That's negative 1. So negative 1 plus 3. And then negative 1 plus 3 is 2. So now my final operation, multiply, I get 6. And number 4, y squared would be negative 2 squared. Notice I'm putting in parentheses there. See, a lot of students will put, they'll put this in the calculator. They'll do this. This is incorrect. They'll do negative 2 squared. What I put in the calculator is the opposite of 2 squared. 2 squared is 4, so it would be negative 4. But we know that a negative times a negative equals a positive. So this, I got to put in parentheses. It's a good habit to put in parentheses, because if I put it in parentheses in the calculator, I do get the right answer of 4. Divided by, and then 13 minus 5. Again, supposed to do all parentheses first, so this would be negative 2 squared divided by, and 13 minus 5 is 8. Now exponents, 4 divided by 8, 4 divided by 8 is a half. Or you put 0.5 if you want. John claims that x plus y, the entire thing squared, equals x squared plus y squared. So is he correct? And maybe you're thinking, I don't know, I don't have a clue. One way would be pick an x and pick y. So let's use the x and y they gave us here. So they gave us x is 5, y is negative 2. Let's plug them in and see. Okay, so I've got 5 plus negative 2 squared equals 5 squared plus negative 2 squared. Well, if this is always true, then this situation should work too. 5 plus negative 2, again, doing parentheses here, so 5 plus negative 2 would be 3. And now exponents. So on the left side, the exponent 3 squared is 9. On the right side, I'd have 5 squared is 25 plus, and then negative 2 squared is 4. And I can see right now that 25 plus 4 is not 9. You know, this would be 9 equals 29. No, it's not true. So no, he's not correct. So yeah, the example above shows how evaluate expressions can be used to check your work. A symbol you should know. Okay, so this is kind of looking ahead to a few lessons from now, is the absolute value bar. So if you see this, there's two just straight up and down lines. Those are absolute value bars. They represent a certain number's distance from 0. Okay, so how far is negative 4 from 0? So here's 0. So we go 1, 2, 3, 4. It's 4 units from 0. So we would say that the absolute value, those bars, of negative 4 is 4. So looking at this graph here, how far is 3 from 0? 1 unit, 2 unit, 3 unit, 3 units from 0. We would represent that by saying that the absolute value of, sorry, this is positive 3, is 3. Now, if I had negative 3 there instead, so what's the absolute value of negative 3? Well, just so happens it's 1, 2, 3 units away, so it's also 3. So absolute value, maybe if you've heard of it before, kind of the fast way of evaluating absolute value is if it's positive, it stays positive, like this, or if it's negative, it becomes positive. But you can't have a negative absolute value because you can't have a negative distance. You've never traveled negative 5 miles. If you went 5 miles backwards, that means you traveled 5 miles. So it's still a positive value. So hopefully that helps. And tomorrow, come with questions, and we'll see you next time.